Welcome everyone to the third Cardano R&D session. My name's Fergie Miller. I'm the Director of Research Partnerships at Input Output. I also help set up the research working group at Intersect that sits under the product committee. So these R&D sessions are held on the first Tuesday of each month, where we invite guest speakers from the Cardano community to discuss research-led topics. And for August, I'm delighted to welcome the Input Output R&D innovation team, who will be presenting a portfolio of technology validation workstreams that are in progress. For the September session, we're actually planning to focus on the Ouroboros protocol, and in particular, Laos, as they hand over their work to engineering. So we won't be discussing those items today. However, we will be providing an overview and update of other streams in progress, and I'll shortly hand over to my colleague David Rosales to introduce the program and each of the workstream leads. The last workstream, committee proofs, is actually currently being proposed to the community for feedback. So we'll have some time for questions afterwards. And for those of you interested in submitting questions, please go to the Activities tab at the bottom of your screen. Well, you'll find a Q&A tool there, which you can use to submit questions, and we'll do our best to get through them all. So just to start, actually, David, I'm going to just take over and just give everyone a high-level overview of the Input-Output Research Cardano Vision Proposal. So this is actually a 5-year vision that we've outlined up until 2030. It's governed by a strategic research agenda, which outlines how IO builds systems. It consists of a 5-year vision for Cardano that is broken down into 9 focus areas, under which sit 34 research streams. And that's then split into annual work programs, which 2025 is the first, for which we've prioritized 20 research and at least 6 technology validation streams. Here are the 9 focus areas that we cover. So as well as Ouroboros and smart contracts, you've got tokenomics, identity, democracy 4.0, Hydra and layer 2, interchains, zero knowledge, and post-quantum. We do this through following what we call an evidence-based methodology, which starts off with research, where we publish a paper and supporting technology artifacts. We then hand over to an innovation team to validate the technology, and that's what we're going to be focusing on today. And then the technology validation teams will then hand those streams over to any engineering team in the community for implementation. And finally, I just wanted to communicate that as of today, the Treasury withdrawal vote for IOR's proposal has now received more than 67% backing from DREPs and from the Constitutional Committee, which is a huge vote of confidence for us, which we don't take lightly. So thank you for all the support. The hard work continues. It feels very much like we're at the starting gate. And with that, I'll then hand over to David to talk you through technology validation work streams.
Thank you, Fergie. Just looking for the slides. Okay, so without further ado, let's go into what we understand in IOG, the technology validation methodology. So, but first we need to understand what are the objectives of the R&D innovation department within IOG. So our primary goals are to serve as a critical foundation to product development, accelerate the delivery of research results to the end users, and mitigate the risk of failure during the implementation phase. This process is designed to make the transition from a concept to a working product as smooth and secure as possible. And this is done via what we call within IoG evidence-based methodology. So traditional software testing is not sufficient for the unique challenges that we have in Web3. The decentralized nature of these systems makes them particularly vulnerable to complex failures and different attack vectors. So we address this by using an evidence-based methodology, leveraging formal methods and cryptography models to rigorously prove the security and reliance of our systems from the very beginning, as Fergie said on the slide before. So IOR process is both iterative and collaborative. So we integrate multiple disciplines, including cryptography, formal methods, simulations, and prototyping to build secure and practical systems. This allows us to catch flaws and make continuous improvements early in the development life cycle, preventing costly issues down the road. So the innovation stage acts as a vital bridge between initial research and final implementation. It involves the innovation team who collaborates with research and implementation teams to validate assumptions, define specifications, and create essential documents, like a reference implementation and test prototypes. This collaborative process includes a critical feedback loop to refine the solution and prepare for its integration into the existing system. And this stage concludes with a retrospective to improve further future iterations. In the flow on the screen on the slide below, we can see a grasp of how these items work together. So the outcomes of the formal method, prototypes, and simulations are the evidence to suggest the variability of the design and the practical implementation. Specifications are also intended to be read and discussed and are developed to ensure that this is a definitive description of the design, and also to streamline and get the most discussions with research and engineers. Formal specifications are detailed and technical and can also serve as the acceptance criteria for the final implementation. Cardano improvement proposals, so CIPs, are technical but less detailed and also justify the need for the change and to serve as a focus for discussion and formal approval for the community. And this is one of the end deliverables that within R&D innovation are taking on the last stage. Next stage. So workstream selection. Our workstream selection is a crucial part of the process. So we ensure that every project we undertake is aligned with the Cardano Vision 2025 that Fergie just give a pic of. This is not a decision made in isolation. It involves consultation with different intersect bodies as the product committee, the technical steering committee, and most importantly, also the Cardano community. So, for example, projects like the development of committee proofs and the library infrastructure are a direct result of this collaborative process, addressing key needs identified by the community. And last but not least, we have the closure. So we prioritize transparency through the whole life cycle and consistently communicate the evolution of each of the different projects and its outcomes to the community. As a project nears completion, the innovation team performs a formal handover. So we share the results and documentation with the community and specifically with the future engineering team who will be responsible for the implementation. This ensures a smooth transition and helps to bring the project to fruition. The latest technology validation workstream is serving as a flagship example, featuring an open repository and a monthly video and a broadcast update, very similar to this fashion, but every month, which I encourage everybody that is interested in layers to join. So now we will go I'll take a peek onto the different work streams that we have. The first one is going to be Ouroboros Phalanx with anti-grinding. So I'm giving the voice to Raphael, so we'll explain us a little bit more. Raphael, the stage is yours.
Thanks a lot, David. So hi everyone, I'm Raphael. I was the cryptographer of Ouroboros Phalanx. So it was a consensus project. Oh, can you stay on the first slide? Sorry. Thank you. It was a consensus project which started in October last year, has taken about 9 months so far, and around full-time equivalent people. The RSL maturation increased from level 2 conceptualizations to 4 prototyping. And yes, we can go to the next slide. Thank you. So the goal of Ouroboros Phalanx was to increasing Cardano's protocol security by increasing the computational costs of anti-grading attacks. So more precisely, in Cardano Pros, we rely on random nonces. And unfortunately, the random nonce generation algorithm is biasable. That means that in a very specific context, an adversary can influence the nonce. And so, for instance, select the randomness, which will give him the most rewards for the next epoch, among other examples. So what we decided to do is to increase the cost of each potential nonce attempt, and so anti-grading attacks, so that the anti-grading attack complexity increased by a factor 10 to the 11, but the network can still bear the costs thanks to the use of cryptographic functions. So we use more specifically asymmetric cryptography, so that the verification, and so what every node would have to compute on-chain live would be much lower than what an adversary will have to compute when they are performing an attack. The main benefit of it is increasing security, but the second benefit is actually to reduce the settlement time, because if we reduce the risk of an attack, this means that we can settle blocks much more quickly. So we reduce the settlement time by a factor 20 to 30% compared to Ouroboros Phalanx without Phalanx. Next slide. Thank you. So the work plan was as follows. We first wanted to demonstrate that the attack is possible and in which context it was possible. We wanted to provide some information about the probabilities of an attack being possible on the course of the attack. So all of this led to the publication of CPS, Cardano Problem Statement document. Afterwards, we worked on a solution. So we designed, we developed, we prototyped and benchmarked the solution, and this led to a Cardano Improvement Proposal, so a CIP. On top of that, we produced a prototype as well as AGDA specifications. So the current status of the project is that the CPS was merged. The CIP was submitted about a week ago. The cryptographic prototype has been implemented, benchmarked, and is open source. The AGDA specifications are being updated. There's a final pass being done. And the impact of finality is still under review. That's it for the anti-grading Ouroboros Phalanx project. Thank you.
Thanks, Raphael. Okay, next one will be Dominik with Jolteon Liveness. The stage is yours.
Thank you. Hello, I'm Dominik Zukowski, and I'm here to give you an overview of the Jolteon Liveness workstream. Next slide, please. So what is Jolteon? Jolteon is the chosen consensus protocol for the substrate-based partner chains platform. We have in the previous work, starting from the bigger picture, this work has been going on for a good while, well over a year, and we have delivered a set of outcomes already. Most prominent out of those is the mechanized safety proof, and this has happened in the late March. Now, after performing that work, we chose is a big word. It made sense to follow the liveness of this protocol. Now, why are we doing all of this work? The goal, the overarching goal, is to pave the path to build a production version of the Jolteon consensus protocol so that the partner chains platform has a very solid foundation to be standing on. All right, so what is liveness? Safety, I'm leaving for later. One can follow up on our published work already. But what is liveness? Liveness is one of the core properties of a consensus protocol. Now, liveness is significant in any distributed system because it means that a set of validators, set of participants can agree on a particular piece of information or, for example, the state of the chain. But from our perspective, from our usage of it, it is most important because it defines the borders on where the property itself holds up. So for our applied, engineered, and evidence-based approaches, it means that we are able to identify the borders and propose strategies that will mitigate, for example, total failure under poor liveness conditions. So that's the ambition, and we are going to achieve this by mechanizing the liveness proof. This means that we're able to mitigate, well, reputational risk, sure, but total collapse too, which is very important in our opinion. The question becomes, what is the innovation? Why are we doing this? The work that is available outside of IOG is, for example, Concordium Jolteon implementation or Aptos Jolteon implementation. These are very fine implementations, but they made a leap. They analyzed the research paper and translated it into an implementation, assuming that the research paper is correct. We also do that. But the innovation that we're proposing is that there is room for improvement. There is a gap between the definition and the implementation. And this gap is a formal model and the mechanized proof. And this mechanized proof brings the implementations a little bit closer to how it's defined in the research paper. So that's the innovation. That's what we're trying to propose, and proposing and succeeding as is shown by the mechanized proof. Next slide, please. As I mentioned, this whole effort has been going for a good while, and we've already built things, I'll mention which, and published things. So the mechanized safety proof is already, for Jolteon, is already a published research paper, and the proof itself is publicly available on a GitHub repository. We've also internally performed engineering efforts. As David mentioned, we want simulations, we want proof of concept. We want to be able to relate the model, the proof, the research paper to something that's tangible, that we can actually run and see and measure and verify for correctness ourselves, not only outside of that. So these are the inputs. We're building already on some things that have been delivered, and the next step was to focus on the liveness, as I mentioned. And we've spent the Q2 of 2025 to show feasibility of a mechanized liveness proof for Jolteon. So this is done. We are convinced that a mechanized liveness proof is feasible. And the next 2 quarters, we are pursuing it. And for now, it's going well. So we're very optimistic that it can be done, and it will be done. Will it be done by end of year? No promises. This is R&D innovation work. In the meanwhile, since it's for partner chains and since it's a substrate-based implementation, we are also working on a prototype that is integrated into the substrate foundation. So this means that we have a consensus protocol that is running on substrate and follows the definition that is very near or near perfect to the model that has been defined in Jolteon, in Agda for Jolteon. Regarding the things that we want to, the deliverables, the things that we want to publish is yet another research paper that will document the liveness proof, the mechanized liveness proof when it's ready, and verifications. So as part of this effort, we're also chasing a way to verify a operating node. Now, this is still early days, but we are very confident that a way to verify behavior for a running node is possible, and we're calling it that race verification conformance suite. And that's what we're going to deliver out of this work stream. Now, Obviously, and this isn't mentioned in this slide, we want to enable partner chains platform and their go-to client. So that's the biggest deliverable, but this will happen as an effort after this. That's it. Thank you so much for listening to me.
Thanks, Dominik. Next on the stage is Recursive Snarks with Dmytro.
Hey everyone. Yeah, I'm here. Yep, my name is Dmytro and I'm a technical architect at IOG and happy to share a bit about our recent work in RSnark's workstream, which focuses mainly on the use of Halo to Snark on the Cardano blockchain. This workstream started in 2024, and to this day we have really some cool results, which I will share with you. Next slide. Yeah, thank you. First of all, a few words about snarks in general and why we are interested in using them. Snarks are a type of a proving system that lets you prove some complex statements without revealing all the details behind these statements. For example, you could claim that a certain hash represents the state of a blockchain, and with a snark, you can generate a small proof that verifies this claim without exposing like the actual data about the whole blockchain. It's really very powerful concept that enables all kinds of applications like building trustless zero-knowledge bridges, creating ZK rollups, or developing privacy-preserving applications. The potential use cases are really broad. And Halo 2 is a particular type of snark proving system. It is a modern scheme that allows very efficient provers and very short proofs, which are particularly suitable for on-chain use. But even though the verification runs in milliseconds on regular machines, directly porting the verifier to Bluetooth makes it too costly to run on-chain. So we had to apply a range of optimizations to make it work on Cardano. And that was actually the main goal of the workstream, to see if it's actually possible to verify Halo 2 proofs inside Bluetooth smart contracts. At first, it wasn't clear how costly that would be. Snark verifiers, especially Halo 2, they involve very heavy cryptographic computations, which are usually very expensive to run on-chain. And another notable feature why we selected Halo 2 is that it supports efficient recursive verification. It's kind of recursive proofs are kind of a special proofs that can verify another proofs or even a chain of other proofs, allowing to construct so-called aggregated proofs. Now a little bit about our concrete achievements. We started the work stream by implementing proof of concept Halo 2 verifier for a very simple circuit. To make it feasible to verify on-chain, we had to tailor the verifier to a specific circuit and apply various optimizations. David, please, previous slide. I will, yeah, thank you. Then we developed a tooling that allows automatically generate plains code from a given Halo 2 circuit implementation in Rust, which really eased testing of various proofs. We tested our verifier with several circuits. One of the most prominent examples was verification of ATMS signatures. It's a threshold multi-signature scheme that can be useful in various constructions, including bridges. And we were happy to confirm that it's indeed feasible to make Halo 2 verification inside a Bluetooth script, which fits into all on-chain limits. And yeah, some time ago we showed a demo on mainnet of verification of ATMS threshold signature. Along the way, we also identified some key bottlenecks in on-chain verifier, and we proactively proposed a CIP to introduce built-in support for multi-scalar multiplication. It's an important cryptographic operation that appears in many cryptographic protocols, including Halo 2 and Gross 16, but not only. And having it as a built-in will help to reduce the on-chain cost of such kind of protocols. And in addition, the team experimented with recursion as well. We also developed an efficient Halo 2 chip for foreign field pairing checks. It's a very important component in constructing practical recursive proofs. Yeah, next slide, please. Yeah, just to summarize, at the moment, this work stream is essentially finished. The deliverables are being prepared for open sourcing, and soon you will be able to look into Plutus Verifier and play with it. It's considered to be a prototype as there was no auditing, but I still think it can be very useful for the community to start exploring different use cases that use Halo 2 proofs. And also the MSM CIP was accepted and now is being implemented by the Plutus team. So we hope we'll be able to enjoy this improvement in Plutus very soon. And yeah, thank you. That's all.
Thank you, Dmytro. Thanks for the presentation and great work accomplishing the results on the team with the team on recursive snacks. Okay, and next one is going to be Alex with proof of stake. The stage is yours.
Hi, I'm Alex Slesarenko, and I'm the architect of the proof of stake workstream, which is also known as Minotaur. Next slide, please. Minotaur is a novel consensus protocol which can be thought of as an extension of Jolteon, which Dominik presented before. We have developed it to solve a fundamental challenge for new proof-of-stake blockchains, the cold start security problem. When a new proof-of-stake chain launches, it has no or small native stake distributed among select participants, making it vulnerable to inexpensive attacks. Minotaur addresses this by allowing the new chain to leverage the economic security of established networks like Cardano and Ethereum. Our key innovation is the concept of virtual stake. This system allows operators to participate in securing a new Minotaur-based chain using their existing assets on different chains without having to move them to the new chain, while also earning additional restaking rewards. We have designed a generalized multi-chain, multi-asset protocol, which we call proof of stake. To ensure the integrity of the system, Minotaur includes a comprehensive fault-proof mechanism adapted to cross-chain nature of the protocol. This creates a strong incentives for honest participation and penalizes bad actors, building a secure, reliable foundation for any new Minotaur-based chains from its start. Next slide, please. Over the course of the project, we have made significant progress and completed most of our goals for the initial phase of technology validation. We formalized the protocol design, built the core library in Rust, and successfully simulated the committee selection mechanism in the simulation environment of Jolteon. We also developed proof of concept connectors to demonstrate how we can trustlessly read state from both Cardano and Ethereum. In the process, we identified missing Cardano features, more specifically lack of Merkle commitments in the block header. We created a Cardano SIP to address this. We also tried to use Dmytro to certify block headers and found that this use case is not supported by Dmytro yet. We reported this issue in the Dmytro repository as well. In addition, we created our initial formal model in Agda as a precursor to a full safety and liveness proofs for the new protocol. So this brings me to our current status. The project is now partially suspended as innovation workstream. We have successfully advanced the implementation to the edge of software readiness level 4 and completed the prototypes, providing the technical viability of the Minotaur concept. However, our engineering work has outpaced the finalization of the underlying theoretical protocol research and security proofs. And to move to the next stage, in particular building a testnet ready prototype, we are dependent on those completed proofs. Therefore, we have made a decision to pause engineering work for a while. This prevents doing work on unstable foundation and allows to de-risk the project long-term and allocate resources more efficiently in innovation team. All our deliverables have been documented and the innovation team is ready to resume work as soon as the foundational research is complete. Thank you.
Thank you, Alex, for explaining about proof of restake. Okay, and next one is going to be like client infrastructure, or also named Kfish. For this one, so the technical, as Fergie said, August is a really bad month to do this kind of Monday meetings. So the technical architect is on holidays, but he has prepared us a video with.
Hi everyone, I'm Nicolas Henin, technical architect at IoG Innovation Group. Today, I'm excited to introduce a newly launched initiative called Kfish, a light client protocol designed specifically for building transactions on Cardano in a resource-efficient and trust-minimized way. The initiative officially kicked off this month and builds on fresh academic research, including a peer-reviewed paper published in June that lays out the protocol's foundations. Over the next 6 months, we'll be moving from theory to prototype, validating its real-world potential and preparing for future integration. So without further ado, let's dive into what Kfish is all about. So what is Kfish exactly? At its core, Kfish is a light client protocol designed for UTXO-based blockchains like Cardano and Bitcoin. It allows users to build and submit transactions without syncing the chain or knowing the full ledger state, which is a game changer for low-resource devices. The protocol introduces a client-provider model. Light clients delegate the actual transaction construction to service providers, who are compensated directly within the transaction itself. Why now? Because as ledger volume grows, especially with changes like layoffs, lightweight interaction is shifting from a nice-to-have to a core requirement. Today's alternatives either rely heavily on trust or are just too heavy for constrained environments like mobile or IoT. Kfish addresses this by offering a communication-efficient, trust-minimized solution specifically focused on transaction building. Now, it's worth noting that data querying, another important aspect of light clients, is out of scope for this first phase and has its own challenges. We're deliberately narrowing the focus to make meaningful progress on the transaction path. Now, innovation-wise, what makes Kfish unique is the underlying cryptography. It uses zero-knowledge proofs and a novel form of weakly blind predicate Schnorr signatures. These enable a two-party protocol that minimizes trust and communication, preserves privacy until posting, and still results in a valid, standard UTXO transaction. In short, you describe what you want, and Kfish handles the rest securely and efficiently. Now that we've covered what Kfish is and why it matters, let's take a look at how we plan to deliver it. Our work plan is structured into 5 focused tracks. First, we define applied use cases. We'll identify minimal and impactful transaction types such as payments or minting to demonstrate Kfish's real-world value in light client settings. Second, we move on to prototyping and benchmarking. We'll build a minimal working prototype focusing on basic UTXO transactions based on the paper's implementation. We'll also benchmark prover and verifier performance using CIRCOM and Groth16. Third, we design the incentive model for service providers. The goal is to embed compensation directly in the transaction so that service providers are rewarded fairly while reducing the risk of free riding. Fourth, we formalize the security protocol. we'll develop a machine-checked formalization using AGDA that captures key properties like correctness, safety, and the private until posted guarantee. Fifth, we explore how to extend transaction capabilities. This means evaluating how the protocol might support smart contract interactions in future phases. As for deliverables, we'll produce documentation covering the use cases, smart contract extension scope, and service provider incentive design. On the software side, we'll deliver the minimal prototype, benchmark results, and supporting tooling. All of this is aimed at validating the Cavefish protocol in realistic conditions and preparing it for integration into Cardano's infrastructure. Cavefish is a small protocol with big implications, and we're excited to prove its value as we move from concept to prototype in the coming months. That's it from me. Thank you for listening, and see you next time. Hi everyone, I'm Nicolas. Hi everyone.
Okay, thanks for listening to the recording. And last but not least, we have a proposal to make today. Is a work stream after finishing recursive snacks that the team is digging into. This is called committee proofs, and Dmytro will also explain us a little bit what's about it.
Thanks, David.
It is yours.
Yep. Hi again. Yeah. I'd like to introduce this new potential work stream that we believe could bring significant value to the Cardano ecosystem. So in AirSnark's work stream, our focus was mainly on developing the core tooling to verify Halo 2 proofs on Cardano. But now we actually want to apply this tooling for a particular use case to enable a trustless cross-chain bridges between partner chains and Cardano. This could take us all the way to SRL level 6 prototype of a ZK-based cross-chain bridge. And yeah, so this work stream is expected to take the next 3-4 months. All right. Now a few words about the technical aspects of this work. As it was already said, Partner Chains is a framework developed by IOG that allows launching specialized blockchains that operate in parallel with Cardano and kind of leverage its security properties. What's important here is that Partner Chain, they use a BFT-based consensus protocol, which is governed by periodically rotating committees that are composed of Cardano stake pool operators. And now, to enable true interoperability between a partner chain and Cardano, we need a bridge, a bidirectional bridge, one that not only lets partner chain to receive messages and tokens from Cardano, but also allows Cardano to actually receive data from them. Forward communication from Cardano to partner chain is relatively easy since partner chains can directly observe the Cardano blockchain. The challenge lies in the reverse direction. Cardano can't actively track like every partner chain, which makes receiving and verifying messages a bit more complex. So how we can approach this problem? To build a secure cross-chain bridge from a partner chain, Cardano needs to know what the current consensus committee is at any given time on the partner chain side. That is very important for cross-chain communication, because if Cardano knows which committee is active, it can verify any messages that are coming from the partner chain and signed by that committee. To make this work, we need a reliable way for Cardano to track and verify how the partner chain committees evolves over time. In practice, that means actually implementing a smart contract on Cardano that can certify each committee rotation. And that's really the goal of this work stream, to prototype a mechanism for certifying committee rotations using a chain of trust approach. In this model, the current committee signs the public keys of the next one, creating a verifiable chain of trust. This concept was originally proposed in the proof of stake sidechains paper, but now we want to bring this into life in a practical implementation. And this is where actually ATMS signatures can come in handy. Since partner chain committees can be quite large, sometimes involving hundreds or even thousands of nodes, we plan to use snarks to aggregate the signatures. And this allows us to succinctly prove that a threshold number of valid signatures from the active committee is present without blotting the verification process. Next slide, please. Here is roughly the plan for this work stream. At first, we aim to integrate a beefy bridge gadget into partner chains framework. This gadget was initially introduced in Substrate SDK, and it allows to collect signatures of a particular data from the current governing committee. In our case, these data will be the keys of the next committee. The next step would be to aggregate these signatures into one shared Halo 2 proof, and then prototype a Cardano smart contract that could verify such a proof and keep track of committee rotations. We also aim to formalize this protocol and formally verify its properties. And this is essentially a groundwork for constructing secure, trustless cross-chain bridges. Yeah, that's probably all for a short introduction. I hope we can get support for this work.
Thank you, Dmytro. So, Fergie, going back to you, as we already went through all the different work streams on the new proposal.
Thank you, David, and thank you to the rest of the team for those presentations. I don't see any questions yet, but for those of you who do want to ask a question, please go through to the activities icon in the bottom of your screen. I think it's the one with the 9 dots that makes a square, and you will see a Q&A option there to submit a question. So we'll just wait for a moment or two to invite anyone who wishes to submit a question to do so. We went, so this committee proof stream, the last stream, is a proposed stream. The last proposed stream we undertook was actually light clients, where we made a presentation in the spring to the product committee and went through a due diligence process with them. Fast forward a couple of months and we find ourselves speaking more directly to the community. So we will upload details of this stream onto the Cardano forum and invite discussion there. And actually, for each of these presentations, like we're in the process of doing with the previous 2 Cardano R&D sessions, we'll be uploading video clips and dissemination material up to the Cardano forum as well. So that information will be publicly available to the community. So I still don't have any additional questions. I'll hang on for another minute or two, otherwise we'll wrap this session up early. So yeah, if you've got a question, please submit it online. Okay. Well, I think
you want to tell us about the next session, which will happen in September?
Yeah. So the next session will have an Ouroboros focus. The June session was focused on layer 2 and Hydra. The July session was focused on tokenomics. The August session today has been focused on technology validation. So more of a stage focus rather than a thematic focus. But in September, we'll return to a thematic focus. So that will be focused on the Ouroboros protocol. We'll provide an overview of the 8 or so research streams that are being proposed under Cardano Vision, of which a number have been prioritized for 2020. And we'll also have a dedicated session for Ouroboros Laos. That stream is and David, please chime in here, but that stream is coming, that innovation R&D stream is coming to an end. So that is being handed over to engineering for them to go into the implementation phase as we speak at the moment. Obviously, ongoing support will be provided, but that would then become an engineering stream for implementation. So moving through TRL 5 and starting working towards testnet and then mainnet release over the coming quarters. So that will be the focus in September. I don't know if that provides a good overview, David.
Yeah. I mean, maybe not doing the handover yet. We have people from IOE Cortec Engineering in the project, but yeah, we expect the CIP to be finished and drafted on layers on the CIP GitHub repo end of the August, beginning of September, and then going through the whole process and doing the final handover to the implementation team. But yeah, that's pretty much, yes.
Okay, great. So if no one has any questions, we'll leave it there. Thank you all for making the time available. I know it's August, I know it's holiday season, and I know a number of people are traveling to Las Vegas for Rare Evo. Thank you, David, and to the R&D team for your time preparing those presentations. There's a lot of information there. So yeah, we look forward to sharing that on the forum over the coming weeks. All right, have a good day, everyone. Thanks very much.